Hello everyone, this is Rebecca Arvin with the Water Environment Federation. I want to welcome each of you to the Operational Optimization in Wastewater Utilities webcast. Before we begin, I would like to quickly review a few logistics. All the PDF PowerPoint presentations are available for downloading at West's FTP link. This link was distributed via email yesterday and will be distributed again tomorrow for anyone that registered after the time of distribution. The FTP link for this webcast also has information on how to receive professional development hours for those eligible to receive these training credits. There are 2 PDH credits for this webcast. You will need to complete the evaluation form to receive the PDH certificate. Your feedback on this webcast is important and helps identify future webcast topics that are timely and helpful to you. Please follow the PDH instructions and check with your state accreditation agency on how to receive this credit. During this webcast, while you cannot speak directly to the presenters, you will, however, have an opportunity to submit questions by typing in your specific question via the question pane that appears on your PC. Mike Sweeney will be accumulating questions and direct them to the presenters at the end of the webcast. We will be recording this webcast. A link will be sent to all registered users tomorrow so that you can share with other colleagues who could not attend the webcast. If you have any additional questions after the webcast is ended, please email webcast with an S at west.org. Before we get started, I have a couple of poll questions. We'll go ahead and launch the first one. It is, how many people are participating in the webcast today at your computer? If you're participating by yourself, please respond 1. If you're participating in a conference room, for example, or have several people gathered around your computer, just do a quick head count. Okay, it looks like we have most of the votes in. We have a lot of people participating by themselves today. And then I have a second poll. It's, why are you attending this webcast? For educational reasons, a refresher, new information, or other. And if you respond to other, if you could just put that in the questions box, that would be great. Great, thank you so much. Looks like we have a lot of people for educational reasons and new information. So I'd like to thank all the speakers for joining me today. Tom DeLora is going to be our first speaker, and Tom is currently the chair of West Automation and Information Technology Committee. Tom?
Thank you, Rebecca, and I want to welcome everybody today and thank you for attending this webcast. As Rebecca said, I'm Tom DeLora. I'm from Aramosa International. I have the privilege of serving as the chair. of WEF's Automation and Information Technology Committee. This topic is of keen interest to our committee. We believe that automation and information technology are key to achieving operational optimization. When you're through listening to this webcast, please consider joining any of WEF's wonderful committees, in particular the Automation and Information Technology Committee, or the other one that's involved in this webcast, the Utility Management Committee, and utilize our resources to help you address this wonderful topic. The agenda we'll go through pretty quick today. We have 2 hours to go through what we're going to cover. After I cover this brief introduction, we'll have 3 wonderful speakers involved with us today. Dr. Vitasevich from Los Angeles, who also serves as the Vice Chair of the WEF Automation and Information Technology Committee. He's an author, a researcher, a workshop leader, a writer, an educator, and just a wonderfully fun person. All of the speakers today are good people, and you'll find that they are dedicated to our industry and have some wonderful insights to share with us about operational optimization. From Cello's perspective, you'll learn about the term itself, oftentimes misunderstood. Many people throw the term around as doing more with less. What do we mean by operational optimization? So Cello will introduce us to the definition itself. What do we mean by optimization in the wastewater industry? Varouj, Assistant General Manager of the Los Angeles Bureau of Sanitation, will take us through what operational optimization means to him in the actual wastewater treatment processes. Varouj's 33 years of experience with designing, constructing, running, operating, starting up wastewater treatment plants will be invaluable to that perspective on how it applies inside of wastewater treatment plants. Bijou George, the Interim Executive Director of Greater Cincinnati Waterworks, will bring a perspective on optimizing the watershed. That comes from Bijou's experience as having served as the Deputy Director for Cincinnati's Metropolitan Sewer District. He's going to show us some of the things he was involved with while he was there, serving as engineer, supervising engineer, assistant superintendent, and deputy director. We'll close the webcast with Mike Sweeney, chair of the other committee sponsoring this webcast, the Utility Management Committee, and then we'll open it up to questions. And hopefully we'll provide you some answers. So I told you a little bit about the two committees involved. Our Committee on Automation and Information Technology is looking at things like the utility of the future. And if you go to WEF's website, wef.org, and you look at the subject of the utility of the future, you'll find in that report, recently published, that automation is vital to the future of wastewater organizations, particularly in the take on operational optimization. If you look at the Utility Management Committee, you'll see that effective utility management has been a main topic in the call for papers of the Utility Management Conference. Operational optimization also aligns with WEF's recent strategic plan that was published, wherein they note driving innovation is key to the future of our organization. Now let's do a real brief introduction on the topic and then the speakers. Operational optimization is one of the 10 attributes of an effectively managed utility. And when we're done with today's webcast, you can either find this link through wef.org or by going directly to the link shown, watereum.org. Watereum.org came about as a result of a collaboration between 7 different organizations, including WEF. It goes back to 2007, where an agreement was signed between these organizations. If you go onto the website, you'll see a fact sheet, you'll see brochures, you'll see a primer, you'll see case studies and further definitions on what is meant by the 10 attributes of effectively managed utilities. You'll find this wheel, which depicts a continuum. The attributes are really sort of a succinct indication of where effectively managed utilities focus their efforts, what they are striving to achieve. And down at 4 o'clock on the wheel, you'll see highlighted the topic of operational optimization. So what are we going to do today? We're going to have speakers tell us what this term means. Despite everyone telling you what they think it means, we're going to talk about how you might know when optimization has been achieved. What actions might you perform to reach optimization, to move towards that goal? And our 3 wonderful speakers will give you their view on it, showing you how it works in our business. And then Mike Sweeney will wrap up for us all. So right before I turn it over to Cello, he will talk about optimization and the subject itself. What does that term mean? Varouj, again, will talk about optimizing inside the treatment plant. Bijou will talk about optimization in the collection system, and something very wonderful he's done talking about integrated watershed management. Mike will then put it in the perspective of how all these things tie together from the utility manager's perspective. So with that, let's have some fun. Let's turn it over to Cello.
Thank you, Tom, for the wonderful introduction. I'd like to provide some definitions in the context for optimization in terms of how it could be used in wastewater treatment and planning and operations. So when we look at the meaning for optimization in the dictionary, we'll find that it has 2 parts to it. The first part, highlighted in yellow, is sort of a generic description of doing a wonderful thing with about something. It's a process, methodology, making something fully perfect or better. The second one is a lot more narrow, and it talks about optimization as a mathematical term. And it is this mathematical optimization that I'm going to talk about first. So let's assume that we're trying to get a good deal on a loaf of bread today. What we would do is we would look at the prices of bread loaves in different bakeries that are within our driving range. We would find out if there's a function that describes these prices. And then we might look for the place that offers the cheapest loaf. So what we've done here is we've decided on our metrics, which was the cost. We've collected the data, and we found a function that describes this topic, and we found the minimum. So if we wanted to optimize bread purchases not just for today, but over a longer period of time, in addition to these two axes, we would have to add another axis for the future. So instead of getting a line for a function, we may get some sort of a strange-looking surface. So in this case, the optimization equations, the optimization algorithm would look to find a line that is the lowest possible line that connects these lowest dots on this chart. So we would try to use this optimizational algorithm, which is sort of a generic set of equations and tools to take these historical bread prices and future bread prices and give us perhaps a guidance, give us specific advice where to buy our bread in the next month or so. In order to do that, we would also have to have perhaps some other algorithms, some other equations that show how the bread prices are going to change in the future. So in this case, we only cared about cost, but we may also worry about freshness or bread quality. We need to put together what is called an objective function, which will be, we will look for the minimum of this objective function. So if we look at something like freshness, we can think whether we can measure it, and we might say, okay, it's the time since it's been taken out of the oven. And we also may wonder if we have access to this data. So for example, stores may not provide this kind of data. In optimization, there are also constraints. There are things that would limit our ability to act. So our constraints in this case may be that some of the people that we're going to share our bread with, are like our daughter or mother-in-law, have certain priorities, and that also different products have different qualities. So in summary, the mathematical optimization is a generic set of equations or solutions to these equations, and it finds a minimum or a maximum of function, and it automates the decision making. It just tells you what the answer is. So the application to wastewater, one of the examples where such algorithm has been applied to wastewater is in minimizing combined sewer overflows in a collection system. So in that case, optimization algorithm was used to take the historical levels and flows and the forecasted levels and flows to produce the flow set points for different pump stations and position set points for different gates. In order to support this optimization algorithm, we had to generate the forecasted flows and levels, and this could be done using a rainfall forecast, hydrology model, hydraulics, and then this would interact with the optimization algorithm. So this is one specific example of applying mathematical optimization in wastewater organizations. Now, let's talk about this other optimization, which is a lot broader, and I'll just call it business optimization, or it's pretty much synonymous with what is effective utility management is calling operational optimization. So the difference is in the role of technology. In the mathematical optimization, the algorithm makes the decision for us. It's automation. But in this other definition, it is really about providing decision support and providing information or tools to help us make decisions. So it's just a different balance between the two approaches to technology and people. So for example, if we go back to our example of bread, there are such parameters at bread quality that may not be so easy to put into an equation or an algorithm. But we might have a person quite knowledgeable about bread, like, for example, my grandmother, my Italian grandmother, who could look at a loaf and pretty much tell if this is a good one, and she had also a pretty good sense for what the prices should be. So sometimes people can also make these types of judgments quite easily. So if we go back to our example of optimizing the operation of our system to reduce or improve combined through overflows, we should also consider whether this same information, if it's provided to an operator, would yield the same or similar results. So it is really a matter of approach. If we, for example, wanted to improve a library, we could either do it to make the librarian's job easy or to get rid of the librarian. Through the years, I've come to believe that helping the librarian is a lot better way to go about these things. So decisions. Now, these decisions have to be made within the context of different organizations. And there are different levels in organizations. So let's think about car racing, for example. On the day of the race, we have drivers. The people are the drivers, and they look at the instrumentation in their cars, and they have steering wheels, and they're judged by how quickly they get around the track. So that's the operational level that happens right in real time. And on the tactical level, between the races, there are mechanics that inspect and fix the cars in facilities that are specifically designed for that. And the metrics might come out of computerized diagnostic tools to really evaluate if any improvements are necessary. And on the strategic level, a whole new set of people that have to do with design, perhaps manufacturing, marketing, and so forth come to play. They have a different set of tools, and the metrics for on that level may be the number of endorsements that the team receives. So in private industry, it's been recognized that sharing of information between these different levels, operational, tactical, and strategic, is really key to success. So we have the same type of situation, very similar in wastewater utilities. We have strategic decisions that we have to make when we do planning and design long-term, tactical decisions that have to do with things that have shorter time span, and then real-time decisions that we have to make, such as managing inline storage in a sewer system, flow equalization, process control, and infrastructure would be monitoring and managing odor, maintenance of facilities, and so forth. And there are different metrics on each level. On operational level, the product needs to be good and clean, and for tactical decisions, our facilities have to be in good shape, and strategically, we have to keep our rates low. So we've talked about decisions. Now, one way to help in decision making is to provide support that information technology can provide. So we can have systems that collect the data, include analytical tools, and then provide this to the business process to help in decision making. When we look at these systems, we have to consider the business goal, the people involved, and what the functions are. And on the analytical tools, we have to think about technical requirements, system architecture, system components, and also we have to understand the data that we're dealing with. And we need to kind of look at these decision support systems for processes on all three levels, operational, tactical, and strategic. So this area in blue is the domain where IT, information technology, can help in managing utilities. So the first generation of IT systems, sort of like what has IT done for us lately, is that they've developed a number of systems that support our business functions, real-time control, mapping, hydraulic analysis, maintenance, and so forth. So they have targeted specific business function and provided tools that address those specific functions. So we can today ask our IT systems many different questions about our systems. How many complaints have we received from a certain area? Does a certain sensor or pipe need to be fixed? Where is it? What was the level at that slot last week? But each of these systems has a very limited questions that it can answer. So we have to ask questions to many different systems to get the overall answer. And the information, these different aspects of information, is contained and sometimes locked up within proprietary systems that are placed throughout our organization. But the fact is that our business processes in different business units across the enterprise are coupled because they impact each other. So if we had a utility that had these kind of departments, engineering, operations, maintenance, planning, business, and IT, for example, there are strong, if decisions that get made in one organization part of the organization have a strong impact on the other one. And if we look at the organizational chart for some utilities, we would never guess that the treatment plants are actually connected to sewer system, but there is an interaction between treatment and conveyance as well. So if we look at this on a strategic, tactical, and operational level, strategic decisions or tactical decisions are going to have a very profound impact on the operation of the system. So IT systems have evolved through the years. So their first goal was to address single business function issues such as engineering, operations, or maintenance, and they produce tools for that. So that is pretty much where we are today. What is now starting is the generation of tools that would help us integrate the business functions to address the fact that all these functions are interrelated. So we're talking about integration of individual IT solutions to provide better access to data and then business intelligent tools. So if we look at how IT systems are organized within a utility, we can see that different business processes on different levels have their own tools and their own data. So the path to start integration is to think about providing data across these systems so that we can take real-time data, operational data, and provide it to strategic tools, or perhaps build a system that allows us to share the data across all these applications that are been implemented in the enterprise. So if a person is sitting at their computer, there are all these computer systems with functionality in blue, like DCS, SCADA, the customer information system, and so forth, and they each own its own bucket of data. So what we could think about is providing a platform that allows us to connect this data and then to perhaps analyze it and present it to the users. So when it comes to analytical tools, we can think about models for treatment process, hydraulics, risk, financial models, or tools for statistics, forecasting, project management, and workflow that can then access this integrated data. And presentation tools, we're talking about things that include dashboards where perhaps information may be coming from different systems and where we can provide, let's say, an operator with a more complete set of information that's relevant for their work. And a number of such systems have been used to display data from maintenance, from mapping, performance, as-built drawings, and so forth. So what's important is that technology is based on business needs, and it's not just there for its own sake. So when we look at the left column, we may have some reasons why we would need technology. Perhaps we should see if we need to make complex decisions, if we have limited resources, or if we need to integrate different processes. So that will drive the technology end and will allow us to provide solutions that are grounded in the business needs. So in summary, mathematical optimization automates decision-making. Most business processes are better suited for this other kind of optimization, the business or operational optimization, because we need to consider people, process, and technology. So optimization should also consider business processes on all levels and connect the strategic, tactical, and operational. And IT can play a role and enable business optimization by providing systems that allow for integration and decision support. And so we can have a holistic view. So at this point, I'd like to turn it over to Varoush, who will show some specific examples from his experience.
Good morning, distinguished panelists and audience. This is Varoush Apkin with City of Los Angeles. My part of the talk has to do with using some kind of a systematic approach in optimizing the operations of any unit process in a treatment plant. Essentially, we're talking about using a systematic approach, most importantly, having an end in mind. As Stephen Covey says, you need to know where you're going, otherwise every road can take you there. And utilizing the ultimate success formula, which I will be talking about that, which is, again, a systematic approach. Let's talk about systematic approach. Deming talks about, Dr. Deming, who was the quality guru, and many others following him, talking about the cycle of plan, act, and study, essentially preparing a hypothesis, testing if the hypothesis works, check the results, going back to planning, and doing an action, and studying again. This upward cycle tends to help optimizing a process towards consistent result generation. PDCA is another cycle, plan, do, check, act, or plan to do something, do it, check the results, and adjust your course. Having end in mind, obviously, we need to know where we're really going, what outcomes are we after. Why are we doing any optimization? What should be measured? How should it be measured? There are tons of questions that will be asked during optimizing a process. And later on, when I take you through some real examples, probably I will bring the message home better. The ultimate success formula, which was also used by Thomas Edison, he knew what he wanted to do. He wanted to create a light bulb, incandescent light bulb. He immediately took action towards it, noticing if the set of actions get him closer or farther away from his desired goals, and then taking another set of actions. Obviously, as it's been written in the history, he's tried it 10,000 times, and some of the trials prior that was considered failure by others led to creation of other innovations that today we are using. As Cello mentioned, again, I like to also emphasize on the various phases of planning the work. We're talking about operational changes, which are short-term. Tactical changes could be maintenance or a little longer term, and obviously strategic and long-term changes that we must do. Let me introduce you to a few quality tools. By the way, for reference, if you Google quality tools or statistical process control, there will be tons of, quite a lot of tools that a few of them I'll be discussing now that will show you. There are plenty of tutorials on how to do this thing and how to build them in your IT infrastructure and to create certain algorithms to give you the results. This particular one is the Fishbone Analysis. Fishbone Analysis is essentially known also as Nishikawa diagram. Any particular problem that you are experiencing in a treatment plant or anywhere essentially is grouped under either equipment, process, people, material, environment, and the management. For instance, for people, are the resources are adequate? Are they trained? Questions like that are asked in that particular category. In the equipment, for instance, if the problem statement is we have a motor that constantly fails, what are the root causes on the equipment category? Are we having an adjustment problem? Do we have a lubrication problem? Is the installation not adequate? Or parts are defective and need replacement? These are some of the root causes that are generating, for instance, a motor failure. Now, going through this particular tool on looking in any process, obviously going to give you many root causes. However, now we need to distinguish what's most important and what's less important, because as everybody knows, our resources are limited. So frequently I use the Pareto chart. In this particular example, if you have a motor that constantly fails, out of 20 failures on the vertical axis, we have noticed that 11 times out of 20 times we may have an adjustment problem. The pump needs to be, the sheaves needs to be adjusted, and so on. 6 times we have failures had to do with lubrication, inadequate lubrication. 2 times out of 20 we had installation problem. It was installed misaligned or whatever the reason was. And 1 time out of 20 we had a defective part that needed replacement. This particular tool allows you to, again, distinguish between what's important, what's not important. So it would provide you, after doing a root cause analysis, provides you with going in and focusing on a particular issue. The next one, which is one of my favorites on optimizing operations of a treatment plant, is establishing a process control chart, or called statistical process control. If you Google this one, many of these quality tools will pop right out with all the how-tos on how to establish certain algorithms to generate charts like this. In this particular one, obviously, for example, if you are looking at an operation of a primary clarifier, which later on I will discuss in more detail, and you're looking at the effluent quality as it relates to the total suspended solids in milligram per liter on the vertical axis versus time, you notice that a number of the data points fall between the upper and the lower line, which are called the upper control chart and lower control chart, or lower control limit. Frequently, without using this tool, management always interferes and asks why there is such a variability. Well, variability is a good question to ask. However, some of the variability, if it is within the upper control limit and lower control limit, it's the natural variation of the data point. Management should only ask questions when the data points are above the line or below the line. For example, if the effluent quality has exceeded the upper control limit, you can say, what went wrong that has generated this kind of a result? And then use the prior tools on root cause analysis and so on to identify what has gone wrong. If you have a data point that is below the lower control limit, means effluent quality is excellent, you can again question, what have we done so good that has generated such a wonderful result, and try to repeat that. Obviously, this particular chart comes from the Six Sigma or Six Standard Deviation. above the green line, which is the mean, there are 3 standard deviation, and there are 3 standard deviation below that, which the goal is over time we minimize the variability of the particular process variable. The other tool that I frequently use is when you plan things is using a Gantt chart. What are the activities that must go on parallel? When you have an end in mind, you must plan on various things and see which are the short-term activities, which are mid-term, and which are the long-term, which are the strategic ones. This particular chart also always gives me the big picture on where we're going when we're optimizing the operation of a particular treatment plant. Other charts, other tools could be correlation tools, how well 2 variables correlate with each other, such as an effluent quality versus blanket depth in a primary clarifier, and so on. I will take you now to the next slide on bringing some real examples of what we have achieved and what we've done and what were the results. On a simple operation of a treatment plant, obviously operationally when we're looking at these data and using some of the quality tools I mentioned, we need to look into obviously the total suspended solids in, total suspended solids out, or BOD in, out, percent removal efficiency, blanket depth, sludge pumping rates, the sequence of pumping, hydraulic loading rates, sludge solids loading rates, detention time, diurnal flow, and so on. Many times on operational areas we need to do jar tests if we're adding chemical to enhance the operation of a sedimentation tank. In doing the jar test, if you're adding multiple chemicals for coagulation and flocculation purposes, what are the right combination of the doses? Assume that you are doing the right jar test. Do we have the adequate quality assurance, quality control protocols to measure the quality of the material that we're receiving from vendors? Do they change? Do they vary over time? Because that will definitely impact the operation of the plant. Those are, again, another set of activities operational that needs to be explored. What are the final, the best or optimum blanket depth that will generate the thickest sludge quality as well as the best effluent quality? That, again, needs to be optimized over time. As I mentioned earlier, some of these data points the algorithms can be integrated into your IT infrastructure to generate some of these numbers so an operator can readily make judgment calls. In the tactical area, obviously looking at equipment status, chains and flights, sludge pumps, the inlet-outlet baffle. There might be areas that are in dire need of maintenance. Are all the weirs operating properly, or do we have missing weirs? What are the flow regimes in the tank? Do we have a short-circuiting that lifts up the blankets, or what's the situation? So some modeling need to happen. The location to add chemicals, the flocculant, the coagulants as well as flocculants. I remember back from my operation days, it took us like 3 years of trial and error to find the best location to add ferric chloride and polymer to generate the best results with the least amount of chemicals. The strategic actions that helps us optimize a process in a primary sedimentation tank obviously would be looking at the inlet-outlet baffles, construction of the new chemical injection facilities. If the flows are excessive or the loading rates are excessive, do we need additional primary tanks? And are the pumps adequate or the correct type of the pumps? I remember we did go through quite a lot of capital improvement projects on adding primary clarifiers as well as changing the type of the pumps. Well, the results of this particular example one that I showed you over a course of several years was improving the operation of the primary sedimentation tanks from a typical 40-50% removal efficiency range to upward of 90% removal, which is fantastic as far as any operation, any operator is concerned. My example, too, has to do with bringing new facilities online. Obviously, when things are under construction, you need to somehow systematically bring them online seamlessly and then carry on the optimization regime. But essentially, you've always followed a systematic approach. You need to plan up the work and establish a startup team, probably 6 months prior to end of the construction. What do I mean by that? We need to make sure that the team has a clear direction and expectation. The team that we're assembling has operational experience, maintenance experience, people representing various aspects of any treatment plant operation to be present in there along with the construction manager. I mentioned laboratory. There are sampling needs to take place. Where shall it be take place? What the frequency and so on. A lot of these things could be optimized. Sometimes when we're starting a particular process, we overdo things or we totally forget about it. Having clear representation from all involved generates quite a lot of results. Back in mid-80s, the construction folks brought the process up, started it up component by component, handed it over to the operator. Operator folks said, wait a minute, where are the standard operating procedures? What lab tests must be done? Maintenance folks said certain things were inadequate, number of pumps, electrical issues, etc. So learning from all of that, we have applied it to our Hyperion treatment plant, $1.4 billion renovation that we did back in the 90s. And every process that came online was extremely seamless with no problem whatsoever. That was the result of essentially formation of a team, arming them with the right tools, and expecting and giving them a clear direction on how to optimize and move on. My example number 3 is a little bit out of the treatment plant area. It has to do with the sewers, sanitary sewer overflows. We used, again, the same tactics as Dr. Cello mentioned, operational, tactical, and strategic. In the operational area, we added chemicals, intense cleaning. In the tactical area, instituting a new program, fats, oil, and grease control program to minimize the buildup, along with ordinances and controls that need to be placed in our pre-treatment program. Strategically, we had to look into what areas we need to rebuild our sewers, and we started intensely building about 60 miles of sewers per year. What were the results? Essentially, with a baseline of year 2000, Los Angeles was experiencing 687, a little under 700 SSOs per year. And today, the last data I had was for year 11-12, we had 83% reduction in SSOs down to 116. And this year, essentially it's one of the best or the least amount of SSOs in large cities in the entire nation. Again, following the same systematic approach that of optimization that we've had. This essentially summarizes my part of the presentation, and I'd like to pass it on to the next distinguished speaker. Thank you.
Thank you, Varuj. This is Biju. As Cello had already established, he defined the terms and laid a good foundation for Watershed and had to launch from. I'll be speaking about the application of optimization to watershed operations, in particular how to operate or bring the watershed into an operational platform. That's what my talk will be about, but it has two parts. The first part being the strategic element, or how we optimize the watershed from a planning perspective, and the second part is how we operationalize from a tactical and operational perspective, leveraging the IT infrastructure and all other solutions that those are available to us. Again, I'm, as Tom mentioned, I'm acting as interim director of the Greater Cincinnati Waterworks. However, I'm still retaining my title at MSD as the deputy director because we are combining the two utilities, and once we combine, my focus will be the operation of the both combined utilities, water, wastewater, treatment, collections, and also the other services that we offer, such as billing and customer service. Before I get into the planning aspect of the presentation, let me mention some of the optimization we applied at other areas that Cello and Baruch mentioned. For example, from a business process optimization perspective, again, I probably use some of the mathematical models that we used just for somebody in the audience who are a little bit advanced in applying such models just for their benefit, but otherwise you may ignore those terms. I mean, it doesn't mean anything in the context of presentation. You can apply optimization to any business process at any scale or at any level. And similar to any other attributes, which is part of the 10 attributes of an effective managed utility, these all are part of your maturity, as part of your journey. There is no one attribute that performed at a high level or low. I mean, you have to be equally proficient in all to be as an effective utility. So from that perspective, again, this is a critical one for us. If you look at a call center operation within a water utility, I mean, that's a very good example. You can apply something like an airline distribution, and then you can optimize such operations. And then we have done that and then leveraged such even to a level where we commercialize those operations, offering services to others. That's an excellent application of optimization to a business process. The other example I remember about 5 years ago is on the treatment plant application. It was probably one of the most fun exercise I ever undertaken. The largest wastewater treatment plant we own, Milk Creek, we went through an optimization process of the entire stream, treating the any process as a supplier or a service provider to the following business process. It was a very good exercise. The purpose was to maximize the throughput. We used the theory of constraint. Actually, we used the book written by Eliyahu Goldratt called The Goal, which was a fun book even for the operators and the maintenance staff to read, because those of you who have read the book, it's like a novel. Without have the feel of reading a math book, you can understand the concept and apply that. So that was a very satisfying and personally rewarding project for me from an optimization perspective. Now, coming back to the watershed-based optimization project, as some of you may know, Cincinnati is one of the older cities, and we have issues that Baruch mentioned. I mean, the combined sewer issues, sanitary sewer overflows issues during the wet season. We are under a consent decree because to meet or reduce the overflows. The consent decree we have to implement in 2 phases. We are at the stages, parts of the first phases of the consent decree. There was the opportunity presented to us through the consent decree was typically consent decrees are negotiated with the federal, the regulators through the court system. So you typically have a defined solution you have to implement within a period of time with a very defined outcome. We were very fortunate to negotiate a default solution as the base solution, and then if we could come up with a single solution or group of solutions which would have the same benefit as the default solution at a lower cost, the negotiated consent decree allowed us to present that to the regulators to consider. That is a classic example or opinion, for one to apply optimization. So let me walk you through the process very quickly. Again, using some of the terms which are already defined by Cello and also Varooj. As both of them mentioned, it's very critical that establishing the objectives at the beginning is very critical. Again, because just defining an economic model itself for the utilities is very critical, because the traditional model of operating a utility with a rent-seeking economic model, which is if you build a system assuming that the subscribers will pay you a rent for the capacity they're using. But when you are investing massive investments without no prospect of having any customers paying for the excess capacity you're building just for the wet weather is a serious challenge. So you had to really define what are those objectives. So we had to make that decision that the alternate will be more towards creating a competitive advantage to the region, because though since it doesn't provide a capacity which we can rent. So those definitions and objectives were set. Also defining the environmental as well as social and economic objectives are met. Then of course it needs to meet the ratepayer equity too. The second challenge was again applying this consistently through every watershed, because like many of the utilities, we rely heavily on external experts to help us through defining or do the planning as well as some of the detailed design of the project. So we have to make sure that no matter who planned the project, it followed a consistent path or a consistent outcome. So we created defining all the variables and constraints through a process we developed called as a sustainable watershed process, and even we created a manual to support all those who are helping us with it. And going through that, some of the challenge was not all the solutions are equal, because, for example, some of the green infrastructure solutions that we were interested, we had to define that in a way that's cost competitive compared to the direct projects. We classified our solutions in 3 categories, how we implemented. The direct impact means we built and we own those facilities. Enabled impact, we defined them as solutions that somebody else built, but it gave the same benefit. It gave us some benefits, so we compensated them for had we built a direct facility, what that cost would have been for that. That's another project. And then some of them we decided that it wasn't worth us building it, so we chose a strategy of informing and influencing, which means we promote through non-governmental agencies who are interested in promoting such projects, and then use them to make that happen. So adjusting your projects to leverage that within the watershed, that was critical early on, and which has served us very well. Finally, just as a concluding point, once you develop a whole suite of projects, now you have to create a tool. As Cello mentioned, as a strategic solution concluding, you have to optimize it. And we modified one of the existing commercial product offered by one of the expert services, and then adapted for our application. And we used linear programming, as some of you familiar with such models, as the optimization tool. That's typically if you're maximizing the benefit, minimizing the cost, those kind of objective area, that's the most effective tool. And that's helped us to meet our strategic objective of coming up with the solutions that we needed for the phase 2 by the end of 2012 December 31st, and we submitted that suite of solutions to the federal government. This slide kind of shows kind of the opportunity we had using optimization, because as you can see, the real-time control, again, the cost mentioned on that are dollar per gallon unit cost for building an infrastructure. So our challenge is close to 10 billion gallons. Phase 1 requirement is to remove a combined sewer overflow of 2 billion gallons. So trying to find optimization solution, the lowest cost solution was real-time control. We found an opportunity of almost 25% of that 2 billion gallon we could achieve using such models to achieve that capacity. So that has the lowest cost. So optimization, from a strategic decision-making process is not only a good practice, that also has the most economic benefit, as you can see in the order in which you can see here. The second option there is source control, which is separating the stormwater from the combined sewer and then providing some level of BMP treatment to the stormwater, which is about 23 cents per gallon based on the recent cost. And finally, the cost of 40 cents per gallon is what you see there is the building, storage, and conveyance tunnel type of solutions. So this kind of concludes the first part, how we apply the planning or a strategic level optimization. Again, as you can see, again, this doesn't preclude any of the other tools that you use, such as life cycle operation cost, and all those all become inputs to the linear programming software that make the ultimate selections or ranking of the software. Now, moving to the second part of the presentation, as we start building the wet weather systems, like many other utilities, we always operated in isolation. What I mean by that is our treatment systems never acknowledged that collection is part of an operation. It's always like a maintenance system. And now we are creating numerous wet weather treatment facilities, and we have pump stations and also other storage system. So that really created a need for bringing the whole information into a common platform, and then where someone can make decision how we optimize the treatment plant operations or throughput to maximize the wet weather needs. So we reviewed this from multiple perspectives, and then this is the outcome of it, because we are slowly implementing this, one of the probably substantial projects that I've been part of from an optimization perspective, bringing all this information that Cello walked us through. What does it take to optimize a system, and then bringing it on a decision-making platform, and where we can go from there. We are on the early parts of implementation of it. As you can see, we already have many existing systems, but the key is bringing them all on a cohesive platform, and then identifying the gaps. Where are some of the holes, and then how we fill them. And then we can make those decisions, in an optimized manner. The key features we are expecting as part of the integrated watershed management system is, number one, we have to have an overflow management system, since we have to report that back to federal government as a reporting requirement. Water quality, not only the water quality of the overflow discharge itself, and also we have to monitor, as part of the consent decree, the receiving stream. Certainly the infrastructure planning decision, capital investment decision, that's an ongoing process. As I mentioned, regulatory reporting. And finally, optimizing all the materials that involve within it. So integrating these resources has provided a serious challenge how to bring this on a platform. The current technology offerings out there, given us an opportunity to review some of them. I'll mention a few, because the biggest opportunity that we saw is the current ability to manage big data. We are a iFix shop, which means our SCADA system, we use the G product, Prophecy, iHistorian, centric products. the GEIP, the new product platform they are offering, such as the workflow, cost plus, troubleshooter. If you are not familiar with them, you may familiarize with some of those products, including the real-time operation optimization software also, which they have, which will give you a suite of product. If you can bring this information on a SCADA platform, you can apply the software from that family itself and then optimize your operation. So that's the direction we are headed with this integrated watershed optimization. There are three distinct concepts we are following to make this happen. Number one is we have to optimize the resources and efficiencies using the IT platform for the individual unit operations, such as whether it's treatment operations, wet weather treatment operation, pump stations, whichever that is, unit efficiencies need to be realized. Number two is we need to build enough operational intelligence so we can incorporate that in training, not only training, but also improving the operation on an ongoing basis or on a continuous basis. Finally, develop enough enhanced management tools. I mean, not only reporting tools, but also analytics and other such tools we can get out of this to efficiently manage the resource. This is a conceptual view of how we bring all these pieces together. Some of the elements that make up all the components of the operations are listed in here, but one of the key elements of this was just identifying an operation division who will be just focusing on wet weather operation. We just initiated that and we'll be staffing that fairly soon. So there will be an owner moving forward with this. We started digitizing two watersheds. One watershed, Little Miami watershed, is a little more advanced stage of bringing the field information. Just to give you an idea, the digitizing activity of the linear infrastructure goes something, starting with a skeletal schematic, and then you build HMI screens. Since we are kind of embarking on this for the first time, we are finding challenges such as when you try to bring such a large amount of information to a small screen, how do you, display that? How do you manage that? So we are working through that. Some of the early benefits we are seeing is once we bring the historic data back onto the new screen we created, you can kind of do the playback functions that's available on the SCADA screen. Very similar to a hydraulic model used, but a tool that is more familiar to the operation and maintenance staff. That's one of the early benefits we are seeing. But again, that project is somewhere around 25 to 30% complete. We just started initiated the project for the Lower Milk Creek. Again, same thing, digitizing the watershed so we can bring all the information together. Just on another note, the outputs that we can create out of this, they are excellent. This is an example of it. Since we already have the real-time rain gauge information, the first principles hydraulic model, we created this iPhone mobile device application. Now you can download and use, because if you click on any part of our receiving stream based on the overflow conditions and the water quality model, it will show you can fish, boat, or get into any kind of contact sport. So this is in a nutshell, that's our vision from both the parts I talked about. I mean, the strategic level, we have a reasonable tool that's already in place we can use for planning. The second part is the ambitious project of bringing together all the pieces of operational system and the tactical tool into one single platform, so we can start effectively optimizing very much to as an entire enterprise system. That's all I have from my part of presentation. So I'll pass this along to the next speaker, Dr. Sweeney.
Thanks, Biju. Well, I think you might agree at this point that our three utility leaders that are speakers are just scratching the surface of operations optimization. Tom DeLora, who started off our webcast today, talked about the EUM framework and placed, rightfully so, optimization of operations as one of the 10 attributes in a very broad framework. But even within this broad framework and narrowing down to one attribute, you have to agree there is a lot to operations optimization. And again, we're just kind of touching on really two large theme areas, actually maybe three: collection systems, treatment operations, and integrated watershed approach that Bijou George just talked about. Just kind of recapping what Cello spoke about is he put things into a perspective of math-based optimization rather and business optimization. Recalling strategic, tactical, and operations decisions all kind of fit together, and he sliced and he diced kind of through those models. I think Baruj also kind of took it from there and emphasized, I think, very effectively the importance of having a systemized approach. And he went through several, including some tools that are of common use, but some maybe not as common as others in various utilities across the country. Some of the tools he mentioned, and it's just, again, a small list, the Fishbone approach, Pareto diagrams, control charts, Gantt charts, and went through, I believe, 3 examples depicting some of those tools in action. Bijou offered a planning perspective and spent a good deal of time on the tactical operations perspective of a sustainable watershed approach to wet weather control and management. There's not many examples of what Cincinnati is doing out there. It does represent, I think, a unique and holistic and ubiquitous approach as it is in Cincinnati for controlling CSOs and many other aspects that are even of a quality of life nature for that. I think Bijou also says, kind of as a last statement, that there is actually an app for that. And I think that's very forward-thinking and something to consider in bringing people closer to, and the community closer to what it is for Cincinnati, for instance, as a huge fiscal investment in water quality for that region. I think if you put it all together, the common thing that threads throughout the webcast is people, processes, and technology that I think, simply put, you cannot optimize in a sustainable way without considering these 3 critical contributing areas of people, processes, and technology. I think as an industry, we've been pretty good over the years of technology and gotten better at processes, but we still need to pay attention to, I think, in my opinion, the people aspects of it. I think that's what, for this webcast, what utility management kind of brings to the table in partnership with Tom's committee, as to remembering that it is about change management, it is about training and investing, and all 3 speakers spoke to it in one form or another, the people part of it, because you can't do it all with just processes and just applying technology in, again, a sustainable way. So what I wanted to kind of close on is just the idea of this webcast itself, and I want to take the opportunity to thank Wes again for opening up webcasts to the membership. To do a free webcast, to do what we're doing today is not an insignificant thing, and to get our 2 committees together and doing this joint venture, I think is what we're about in terms of delivering and driving innovation, as Tom spoke about earlier. It's important for us as committees, as members, to not forget that our young professionals and our member associations, this is one way to reach out to them for not only thinking about future leaders, but also contributing to the volunteer effort that WEF represents, and that your input on this beginning maybe of a discussion of operations optimization could very well lead to future topics that are even more specific in one of these areas or different areas that might come to mind. Lastly, just maybe a shameless plug on the Utility Management Committee itself, and really how this kind of came about. We did a survey of our committee membership about a year and a half ago, and we are made up, by the way, of these 5 subcommittees, as you can see. Our survey kind of confirmed that the subcommittee structure of our committee makes still sense, and when it came to facilities management, to strategic organization and management systems, and touching a bit on finance, this is what came out of it. There were those areas that involve operations optimization that our membership of a committee of 150 wanted to learn more about. And what better way to do that is not only educating ourselves in a network setting like a committee meeting like WEFTEC itself, but also doing it widely with webcasts, such as what WEF is sponsoring today. So with that, I'm going to go ahead and close my general kind of wrap up as much as I can wrap this up and go to some of your questions. And let me do a little housekeeping here. We've gotten a few along the way. And one question scrolling up here, Bijou, before I get, because I had the same question myself, what was the name of the author and the title of the book that you mentioned early on in your presentation that you thought was a really good read?
Yeah, the book's title is The Goal. The author is Eliyahu Goldratt, G-O-L-D-R-A-T-T, I believe that's how his last name is spelled.
Can you spell that again? I'm sorry.
Goldratt, G-O-L-D-R-A-T-T, I believe that's how it's probably Googling maybe a better option on that one. It's The Goal, that's the title of the book. Okay. It's about how to apply theory of constraint. He explained that just on a simple novel format. Our operators and field staff really enjoyed the novel and got a lot out of engaging them, understanding concept of applying mathematics to process control without having to learn real math.
Very good. Another comment came out that I can turn into a question, I think, to Baruch. One comment was the use of total solids meters to improve the timing for wasting from primary clarifiers. I kind of open up that question a little bit to you. Your experience with instrumentation like that or that specific instrument for managing primary or just clarification in general.
What was the instrument?
If somebody would type that in, I can provide that information to you. I don't have a specific example or what they had in mind. So we'll go ahead and we'll go to the next one, but we'll be on the lookout for that and come back to it.
That's fine. Thank you.
Okay. This is a really good question. I'm going to throw it to Cello. How do you deal with the people part of optimization? How do you get the staff to change their behaviors?
Well, I had actually a slide on this that this is a really difficult thing. I had a slide on this or a couple of slides, but it sort of took them out later on. I think that this is, while in addressing technology issues, we need knowledge. In addressing people issues, we need wisdom. And each organization that I've encountered has a different sort of topology, a different map of different interests and goals and history and culture that is really can be fairly unique. And so while we can have a consistent or maybe fairly straightforward approach to technology, the approach to the people side of things is quite site-specific, and I've encountered that. So something that would work in one organization may not never fly in another organization. So it is a difficult thing to address, and it's also something that, if I recall the many projects that I've been involved with, they very seldom sync or have serious problems because of technology issues. It's usually that is the vulnerable part, the people. So it is a difficult question. I would say that one has to understand the organization, has to understand what different stakeholders really want to accomplish, and try to find a path that that will lead to success. I'll just use one example. One of the problems with dealing with the people issue is that it's also expensive, which means it takes time and money. And sometimes when it's a lot easier to explain to people, you know, we need to rehabilitate this pipe, or we need to put a new pump in. That is something tangible. But I remember working with one large city where it took us several months, literally, to get the treatment plant people to kind of get on the same page with the collection system people. Eventually, that was the critical success factor. But it's really not easy to go to somebody and say, I want to spend this much money just to get these people to talk to each other. So it's a very tricky issue, and I don't have a simple formula. And perhaps it's kind of like, it's a huge topic, and perhaps it would warrant its own webcast and a presentation.
I would have to agree with that. And if we're Twitter, we're trending on this topic right now. Bijou or Varouj or Tom, you want to take a crack at this as well?
Yeah, I can. Again, you know, that's a major issue. I mean, actually, we have a formalized change acceleration process that we use, which we borrowed from General Electric. Actually, it's their own process. Actually, their definition for success of a project goes something like this. The success of a project is defined by Q, quality, times A, acceptance of all the people who are participating in it. So if the acceptance is 0, no matter what the quality of the project is, the outcome is 0. So we firmly believe in that. So we incorporate the various aspects of engaging people in a very systematic way as part of implementing the project itself. We kind of built that as part of the organization.
Very good, Bijou. Did I hear Varouj in there?
Yes, Mike. My experience, that is a really, really important part of it. As you know, we define success by knowledge, experience, and attitude. The important part of optimizing is you got to have the people with the right attitude, the right chemistry together. I think management's role is extremely important to identify what the purpose is, what we're trying to do, and set up a direction. Very frequently, I have seen teams that have been commissioned to optimize processes, and yet not enough direction was given. So I do take it as a management problem and leadership problem. So given that, I definitely believe in management's involvement, not only providing a clear direction and a purpose, but also assisting the teams to remove any particular obstacles that might be in the way. Now, the optimization, obviously in this day and age, we're talking about using certain tools to make things better, obviously using some of our IT platforms. Well, this process has been in place of optimization since probably 70s, 60s, and gets better and better. and more tools we have, more hardware and software we deploy using some of the basic tools that were deployed back in the 70s, is the key thing. Integrating various data systems together to convert the information to convert data to information is extremely important these days. But obviously, training people in what it means, giving them a clear direction, it's a very key thing. As Cello mentioned, although it also is an issue of, it's a very unique thing on organization culture within different organizations, but I think leadership is leadership and management is management, how well you do things or what direction people have to go. And that has probably, it's a common thing that can be used in any organization.
Very good. Here's I think another toss-up question. If you can name one thing.
Mike, I just wanted to mention an example to underline that what Varouj said about management. I was working with a large city some years ago, a client who wanted to automate their facilities, off-site facilities, which is pump stations and so forth, and they called it the de-manning initiative. I'm not really sure that this was the best choice of words, and you can imagine when I show up in a pump station and with a clipboard related to a de-manning facilities, you're not going to get the warmest reception. So I think it shows how important it is that the management truly, exactly what Varouj and Bijou also said, that you really have to understand what the culture is and who the stakeholders are.
Very good. Okay, back to that question I was starting. If you could name one thing that's absolutely essential to success with improvement or optimization, what would it be? Let's go back to, let's go in order here. Start with Cello.
Well, I've had, if we look at, I had a slide in one of my previous presentations about critical success factors, and they're not often mentioned in papers or studies or reports. And on my first project, the key success factor was called Norm, who was the guy who ran the system. And it speaks exactly to the same thing that Bijou has mentioned, that engineers are not smart enough to put in a system that the operator cannot break if they want to. So winning their support and getting acceptance, I think, is the key.
Varouj?
Yes, Mike. I think one of the #1 key attitude is for sure the right people with the right attitude is really, really important, momentous importance. But optimization wouldn't happen without people being trained in how to put the right tool in place to make something better. So training is a very, very key component of optimization.
Very good. Bijou?
Yes, Mike. Again, from my end, it's a gradual process. I mean, as you mature, you have to have some better than the other. But #1 is you have to build a culture, what I call as optimization ready, which is, the acceptance piece, #1. #2, having efficient process, supporting and enabling with the right technologies that people can use easily. Those are some of the critical elements, because that way it doesn't appear like when you move from one to the other, just coming like, something new all the time. I mean, this should just form as the regular business. People should accept this as not a new change. This is just the way how we are. We continuously improve. We look for opportunities, and once become part of the culture, it makes it a lot easy. But building that part is a little bit hard. But once you get there, it gets you going very easily, as long as you can sustain that same interest from the beginning.
Okay. Here's another one, slightly different topic. What are examples of strategies you've used to encourage public input and stakeholder feedback on continuous improvement or optimization? Bijou, would you mind starting on that?
No problem at all, I can, yes. The public input we mostly use in terms of the strategic outcomes, because the planning side. When we launched our Communities of the Future initiatives, that's what we called, since we were building infrastructure for the future with no definite idea what the future is going to look like. So we engaged the stakeholders from businesses, other community leaders, elected officials, all part of, I think we had 3 different groups. One, we called them policy advisors because they advised us what policies need to be changed internally as well as of other agencies that influence us locally. The second one was economic development because this was some of the businesses had an interest in it. So their input in terms of what improvement they would like to see. And the third group was called as Inform and Influence. They were the promoters of this idea to make it acceptable to communities where we were going to make those new projects. It worked very effectively. Actually, as part of that, again, you have to continuously engaging them in a very meaningful way by doing, the community charrettes and those kind of things, so which they all worked very well for us.
Cello or Varouj, you want to add?
Certainly. I think the people part, the communities we serve, their input is very, very important. What people say is, I want clean water. What we say is, well, what we discharge into the receiving water must be less than X milligrams per liter, which does not mean anything to the general public. All they want is clean water. So the issue comes, how do we translate what people want, first getting their input, and then translate it into certain performance indicators that we must follow. People want clean beaches. We translate it, reduce the number of sewer system overflows. So getting the input is very, very important because after all, most of us working for different municipalities, we are serving the general public. So we can't just go on thinking what they want. We need to actively seek their input, translate it into what performance indicators we must follow to give them what they want. Obviously, during the process, we need to make sure that if our baselines are on a particular process, variables are not adequate, how can we improve that using quality tools and following the continuous improvement journey? Hope that answers the question.
Yes. Bijou, this is a specific one meant for you. Did you have to hire additional staff or a new department to run the public information tools? The example in the question written here is the app, which was your last slide, Recreate Ohio River.
Mike, no, we didn't actually. We used an external consultant to do that, so we didn't have any new additional staff. But again, that was our first attempt in building such an app because there was a lot of work that went into it because we engaged what we call as the recreating community, the folks who sell boats, operate marinas, and those kind of people got their input as a focus group, what they would like to see on an app like that, and then it was created to their needs. So we didn't have the competency internally to create something like that at that time. But the engine runs behind it. Of course, that's operated by us, and but just the app itself, no, we didn't hire anybody new other than hiring a consultant to help us with it.
Okay. I'm going to come back to you again, Bijou. This, I think, is meant for you. What is the greatest upstream influence on water quality?
What is the greatest upstream influence on water quality?
Correct.
Yeah.
Yeah.
It's a it's a. Well, I can speak to where we are, Amina, because that is as complex a question as it can come. Our biggest challenge is bacteria. So that is our focus. I mean, that's what we are preparing for the future. But when you're looking at 5, 10 years or 20 years from now, from a water quality perspective, you're looking at the receiving stream, which is, aquatic, support aquatic life, and then those are, the real goal. How do you get there? That's what your journey is. I mean, so if you have to pick just one issue, it's challenging. I mean, how to, answer that from our perspective. I mean, but from a water quality regulatory perspective, our single largest challenge is bacteria.
And a follow-up just came in. What is the source of the bacteria?
It's that's another interesting question. I mean, just upstream or just in our. I mean, again, the sources can be attributed to many places. I mean, there are better technology to source them now than what we used to. Depending on the kind of storm. I mean, if it is the first flush, I mean, then you can assume where that could be from. I mean, that it's very difficult to assume on that. But if it is a continuous source that's coming, which can be attributed, there are ways you can trace them to. There are. I mean, we adopted technology such as PCR to use the DNA identification method to source bacteria, where they originate from. We have an expert in-house, that's their specialty, and then also we collaborate with UC identifying some of them. The work going towards in that is just at the very early stages for us to say in a very conclusive way, this is what exactly it is. But our approach to pollution is source control, identify the source, and then find the best way to control it, as opposed to put them all in the the sewers and then using that as one treatment method, because then as we society get better dealing with the pollutant at the source, then you have an issue of you lose that benefit that the society in general developing.
Okay. Cello, here's one for you. Sometimes the ROI on technology integration is not positive, but the ability to communicate across all platforms is essential. How do you make it work for customers who have to support building something that may be very costly?
Well, that is questions are fairly complex today. Yes, return on investment is sometimes a little bit tricky when it comes to some of the technologies. For example, let's start with something simple, putting a flow meter in some place or a level sensor. It is not always easy to predict where and in what part of the future planning process you might need the data from that site. So when somebody tells you how much this sensor costs and what exactly is going to be the payback, it's not so simple. Later on, when you need the flow information and you need to understand what is the nature of your problem, whether it's flow or inflow or infiltration, or what are the things you should worry about when you plan, if you don't have such data, you may pay a high price. So it is a little bit tricky with technology. The other part of it is that, honestly, some of the technologies that have been introduced have also underperformed. And I did a survey of 45 utilities recently, about 2 years ago, through WEF, to ask them about their experience with technology, and it was very interesting, because they perceived some technology, such as, for example, SCADA systems, as being very beneficial, but also rated them as being very high risk, in meaning that very often they had issues post-implementation, during implementation, and so forth. So perhaps we need a different kind of way to assess the contribution and the value of technology, because sometimes sort of this return on investment is not as easily, it's not that easy to kind of put everything into that box. So I think that what I would recommend is to kind of take a step-by-step approach and try to justify incremental investments into technology by some new functionality or benefits to the process and so forth. The difficult thing is that the dynamics of the getting funding is it's sometimes as much pain to get $10 million or to get $10,000 through all the approvals. So sometimes sort of strategic projects that are kind of too big can have a little bit more risk than sort of more targeted projects. I'm not sure if that really, it's a very tough question, so I'm not sure if I really answered it, but I hopefully at least provided some kind of background on it.
Yeah, I think the key, the challenge is you're putting a dollar value on integration, and that enabler, it tends to be very challenging.
Well, for example, if somebody asked when they made the first telephone, they said, well, what's the return on investment? Who are you going to call?
Right. Yeah.
Well, you kind of have to go, it may not be that easy, so one has to make assumptions.
Right. Farouj, here's a question. What future would biosolids management hold in terms of operational optimization in wastewater utilities?
Mike, would you repeat that question one more time?
Sure. What future would biosolids management hold in terms of operational optimization in wastewater utilities? What maybe reading into that a little bit might be, we're looking at biosolids differently maybe today than we did maybe a few years ago. But
well, yeah, let me address it from what positives have come about over the years. I think when we first, our system was, for years, decades, was separating the solids from the liquid. The liquid was going 5 miles, clean liquid effluent was going 5 miles into the ocean, and the sludge was going 7 miles into the ocean. But over the years, what have we optimized? Well, we've used better technology on the process of dewatering, for instance. I remember back in the early 80s or late 70s, we had centrifuges that were generating only 16% sludge. Today, and that meant quite a lot of material to be used either on-site or off-site. Today's machines are producing in excess of 33% solid content for our dewatering, which means half as many trucks are impacting the traffic, etc. So that's probably optimization with the technology advancement. In the past, we had one way of disposing of our solids, sending it to landfill. Well, today we're looking at a diversified option of farming, land application. We're talking about composting. Presently, Los Angeles has a permit with EPA that we're trying to locally also address part of our biosolids straight even from the digesters without even dewatering by injecting it miles into the ground in an oil depleted oil well. That's our Terminal Island Renewable Energy project. So we are trying to diversify. We are trying to minimize the volume and the mass of the solids that are generated. And I believe in the future, probably there are going to be technologies coming up that we can optimize, and each community probably handling some of their own local biosolids and problems. I think we are not there yet. We need to be more interdependent, different regions handling, allowing to address various capabilities that they have. And I think that that interdependency, while also looking at independency, it's important to look at it strategically. So I would say in summary, looking at the technology that we have, process technologies, looking at how we manage the solids, the dryness, the quantities, as well as the last destination, how can we optimize the cost and the entire portfolio of the various options that we have, how do we manage it for the least amount of cost, the least amount of environmental impact all around. So it's been a long journey for Los Angeles, but that's where we are heading. Hope that answers the question, Mike.
Very good. Bijou, here's one. And the scary part of this question is I can actually remember this. In the 1970s, U.S. EPA developed the SWIM model, including rainfall runoff, transport, and treatment. Has the algorithms of this work been applied to incorporate the economics of best management programs and intensive structural solutions to meet future goals? Did you guys use SWIM or similar models to that?
Yes, we do. I mean, that's a model we use as our hydraulic model.
Okay. Very good. Cello, one of your slides.
I actually have some data to show if I can get just a screen on your previous question. So let me just show you. There was a question about return on investment, and this is the result of that survey I mentioned of 45 or 47 utilities, and the things that they found, these different systems, such as process models, network models, documents management, HR, maintenance management, LIMS, SCADA, and so forth, and in terms of the benefits that they brought. And for example, this was their ability to reduce capital expenditures or operating expenditures and overall cost reduction. So there is, and then combined with mitigating risk. So there is some data. If the person who asked this question, I can provide the paper that contains this source data.
Do you know whether it's in the WEFTEC proceedings?
Yes, it is. Yes,
okay.
It's in the proceedings, but my memory fails me. I can't remember which year it was. It was in the last couple of 3 years.
It looks like on your slide you got 2011 WEFTEC session 21.
Okay. Thank you.
No, that's okay. It sounds like it's right. I remember you saying 2 years ago, and I remember that paper.
Yes. So there are also, how they can help comply with regulations or reduce requirements for internal staff or improve workflow. And this is the data from the experience from different utilities, 45 of them.
Right.
Anyway, just wanted to show briefly some of this, to help answer the question.
Very good.
Thanks, Rebecca.
Cello, just sticking with IT, the IT domain as you spoke about it, one slide that you did have talked about the domain being analytical and data gathering. And, the top of the slide had, I believe it was business processes.
That's correct.
One of the topical areas, in fact, a panel discussion at the last utility management conference in Arizona back in March was with IT directors, CIOs, and such. And they said, they kind of alluded to, I guess, a growing trend of getting IT more involved with business process improvement, more direct involvement. Just wondering what your experience is in that regard and what your opinion might be.
Well, I think that some of the things that we're dealing with in IT departments are organizational, and some of them are historical. For example, a utility, let's say a wastewater utility, that has its own IT department will probably have a different experience than a utility that may be a part of a city's administration. So it has to deal with an IT department that's at like the city headquarters that services all, maybe a number of different utilities. Also, so that's one aspect that kind of has an impact. So when we look at, and let's say that the IT is within a utility, we have to also kind of look at history and how this IT department evolved and so forth, because some of the IT departments really have people who understand computers but don't necessarily understand the core business, different aspects of core business. So the greater the distance between the core business and the IT department group or whatever, the more risk is that the consideration of the business processes and the core business is there may be more difficulties. So I think the challenge for IT departments is to become a little bit more customer-oriented instead of mostly setting up rules for security and so forth. So an IT department can become more customer-oriented and more in a mode of serving the business needs and also understanding the business needs. I think that that is the key for the IT departments to become more effective.
Okay. Farouj, how are you optimizing nitrogen control and phosphorus reduction in your plans to meet proposed regulations, and how will this affect changes in your current treatment processes?
Okay, that is a very precise question that I may not be able to answer readily, but on nitrogen reduction, what we did, we had that particular challenge from back in the 90s. So our answer to that was strategic, was spending probably about $130 million in 2 of our water reclamation plants to institute nitrification denitrification process to reduce the ammonia. As it relates to phosphorus was the next one that was asked?
Yes.
Was it?
Yes.
On the phosphorus, right now, because we're an ocean discharger, we don't have that particular controls in our permit, to my recollection. But I think that's something that it's probably going to be out there in the near future. I wanted to also pitch in something on that prior question that Cello was involved. May I do that?
Yeah, absolutely.
On the value of IT. In my department, IT and control systems are integrated one unit. It's a major unit. There's about 70 people working on it. But one of the things that we have done, we had the various control systems in our 4 treatment plants as well as the collection system. And you're talking about training people. It was different because all systems had different systems. You had to train them. When an operator or a maintenance person moves from one plant to another, you have to retrain them. Maintaining a huge number of spare parts, and also the soft cost of our staff to manage various maintenance contracts with different vendors, this was astronomical. So to optimize our costs, our resources in training people and all that, we decided to move into look at this whole control systems as a holistic thing and migrate into one system. So we can save money on training, on minimizing our spare parts, on minimizing our downtime, minimizing managing of the contracts. And presently, that project is moving on in our various facility, and along with that, there will be also integration of the modeling in the sewers, the gauging of the sewers, optimizing our pumping plants. So all of this can be addressing quite a lot of efficiencies and optimizing the system. The other aspect that again, the IT and the control system optimization allows us to do, in case of any catastrophic incidents of earthquake and man-made or non-man-made, we will be able to control our facilities from different various remote control points, from one treatment plant or from the collection side or vice versa. So that kind of capability, which we don't have today, we will gain. We will have it in a matter of few years from now, once this construction is over. I just want to address that particular thing as far as how IT can minimize quite a lot of headaches on non-value added resource demands. Thank you very much.
Thank you, Varouj. Biju, did you want to add something?
Yes, Mike, I can. I mean, let me come from two perspectives. One is from the industrial side. The major shift, at least that we are seeing and preparing, is, as many of you have seen, the white paper produced by GE called as the coming industrial internet, ability to manage large amount of data. Relevance to that for water, wastewater treatment is from three perspectives. One is sensor technology. There's a lot of newer sensors are coming out, very relevant, collecting the ideal data. The second part is the deployment of M2, machine-to-machine communication. There are many the cellular chip manufacturers. Now they have a serious focus on water, wastewater, other technologies where they can bring in such communication. I mean, including Qualcomm. They have a serious interest in this kind of business. So the machine-to-machine communication that's coming our way, coupled with leveraging wireless fixed infrastructure as an infrastructure for communities that we serve. The third one is the cloud computing, the ability to manage a large amount of data. That's going to really change the landscape as we know today. The industrial controls, I think that's very imminent. That's going to really create a lot of value, how we can leverage and use that especially in the applications that I mentioned, to just looking from a watershed perspective. On the other side, the business side, the maturing part we are seeing is IT is no longer a service provider. They are as much or more strategic player in an organization than anyone else. Or any operating divisions or any other function. The major difference that at least I'm seeing is, them contributing as from an enterprise architecture perspective. I mean, looking at data and how we manage. I mean, whether you are still within the city or operating as a separate utility, how we architect your data internally so you can leverage, the deployment of technology much cheaper. Because if you look at the current cost of technology implement, the cost of technology is not that high. The implementation is fairly high. You configure doing those kind of things. I think there's a lot of ground to be gained there, and deploying technologies to become a lot more inexpensive moving forward.
Thanks, Biju. I'm going to ask the panel, just the three of you, Cello, Varouj, and Biju, if you can just very briefly say what's next. What are you focusing on in the next few years in terms of keeping things moving in the realm of optimization? And we're getting close on time here, so please be brief. Cello, can you start?
I would think that to be brief, I would say system integration to better support business integration.
Very good. Varouj?
I totally 150% agree with Cello, because right now we're in the midst of, again, unifying our distributed control system into one. And my next challenge would be not only reduce the data systems and applications that we got, which is in excess of 60, but also integrate them. So integration, as Cello mentioned, is really important. I'd like to see our training, our maintenance management system, and our controls of the processes and also the laboratory results or laboratory information management system. All of that I'd like to be integrated together, which is my next challenge after I unify the entire control systems in our facilities. Thank you.
Yeah, this is Biju again. Cincinnati's focus is integrated operation. As I mentioned, integrated watershed management. Also, we are combining the three utilities, water, sewer, and stormwater. So trying to see efficiencies to be captured by integrating, the operation business processes, so we can be as lean and mean as we can, leveraging on every optimizing opportunity ahead of us.
Very good. Thank you, all three of you. This is where we cue the applause soundtrack. So it's being cued. You can all hear it. No, you can't, but we're thinking in terms of that. I'm going to go ahead and turn it back to Tom DeLaura to close this thing out officially. And once again, thanks, Wef and Rebecca, Arvin, and all the speakers for producing what I think is an excellent webcast. And we do look forward to your feedback, folks, out there. There seems to be a lot of interest in a variety of areas from the questions that we received, and we'll be starting to plan next calendar, WEF calendar year for additional webcasts, and your feedback is very important to us. So we'll take it back to Tom.
Thanks, Mike, and to all of you who hung in there through the webcast. I enjoyed it immensely. I thought it was a very excellent presentation on a topic that many times is difficult to understand. Real briefly, from our committee's perspective, automation and information technology were subjects that people looked at in and of themselves. What's the best way to deploy technology? What's the best way to use these computers? Just to use them. What we talked about today was leveraging them and integrating them, and the advantages to achieving new levels of optimization when things are integrated, and how that truly aligns with effective utility management. So we're excited. We're excited that it's seen as a management topic and not a techie topic. It's a thing that actually does improve the overall optimization of a utility. So with that, on behalf of the speakers, Cello, Varouj, Biju, and Mike, and myself, we thank you very, very much for listening today. On behalf of WEF, where you can go and learn more about this at any time you'd like. Thank you today, and we're going to wrap it up and close it out. So thank you again for your attention and your participation.
The organizer has ended the session, and this call will be disconnected. Goodbye.